Hi and welcome to my calculus clinic. This is Dr. Skadanakla. Today we will be learning about how to apply the quotient rule. And the quotient rule is one of three rules that we use to differentiate any function. We have the chain rule, we have the product rule, and today we will be learning about the quotient rule. When do you use the quotient rule? You would use the quotient rule when you have a function of x divided by another function of x. That's when you use the quotient rule. And the answer would be, it's in the formula book, it's the first function or the one at the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator and then divided by the denominator square or divided by v squared. Okay, let's apply it, and hopefully when we apply it, we should be able to learn more about it as we go along. Let's take a look at the first question, and we have y equals sine x divided by x squared. The first thing you would ask yourself, which rule am I using? It's a function of x divided by another function of x, therefore it must be the quotient rule. So the numerator is always u, so u is equal to sine x. The denominator is always v, so v is equal to x squared. So the first thing is to identify u and v. U is always the number at the top, numerator. V is always the number at the bottom, the denominator. And then the second thing you need to do is to differentiate both. So you differentiate u with respect to x, so du by dx. As you might already know, this is the positive y-axis, this is sine, positive x-axis, this is cosine, negative y-axis minus sine, negative x-axis minus cosine. And you differentiate this way. When you differentiate sine, you get cos. When you differentiate cos, you get minus sine. When you differentiate minus sine, you get minus cos, and so on. So we are differentiating sine. So when you differentiate sine, you get cos x. And then we differentiate v with respect to x. So we find dv by dx. And when you differentiate, as you already know, you drop the 2, drop the power, the 2, x, and then decrease the power. When you differentiate, you decrease the power. So 2 minus 1 is 1. So there will be an invisible 1 there. So let's go back and apply the quotient rule. So dy by dx is equal to v multiplied by du by dx. So x squared cos x minus u multiplied by dv by dx. So 2x sine x. And then you multiply by, and then you divide by v squared. So it's x squared. And that's the answer. That's all you need to do. Oh, clearly you can simplify it. You can take x common factor from the numerator, simplify it with the denominator, so it will become x to the 3 rather than x to the 4. But let's concentrate and focus on applying the quotient rule, and I'm pretty sure you, at that level of study, you should be able to simplify it. I'm confident you can. So let's take a look at this another question. And the next question is y equals ln 2x divided by x cubed. The first step, as ever, identify u and v. U is the numerator, so it must be ln 2x. V is the denominator, x cubed. And that's always the first step. Second step is to differentiate both. So du by dx and dv by dx. Now, I'm going to rub this off because I want to differentiate this. And it's quite complex. I know that when I differentiate ln of x, I get 1 over x. We all know that, but we don't know what is it then. What do you get when you differentiate ln 2 of x? And that's what we are going to do. So this part here, for this part here, you should be using the chain rule. So I'm going to let any letter, choose any letter, a equals 2x. If a is equal to 2x, this means that u is equal to ln a, because a is 2x. So it's going to be ln a. And then I am going to differentiate a with respect to x. So dA by dx. And the answer is 2. You drop the power, which is 1. So 2 times 1, and then x, and then 1 minus 1 is 0. So x raised to the power of 0 is 1. Anything raised to the power of 0 is 1. So the answer of the derivative of 2x is 2. And then I'm going to find the derivative of u, du by dA. I'm not differentiating with respect to x. Please, if you don't know the chain rule, please watch the video on the chain rule. You're differentiating with respect to a, or any other letter that you choose. It could be t. And you will find, and you're going to get 1 over a. From watching the video on the chain rule, so du, so from here, du by dx is equal to 2 multiplied by 1 over a, which is 2 over a, and a is 2x. If you simplify it, you get 1 over x. So what did we actually find out? We just found out that the derivative of ln 2x is 1 over x. Do you reckon it will change if I have the derivative for ln 3x? No, it will still be 1 over x. So now I know that the derivative of kx is equal to 1 over x. Now let's differentiate the other one. So I'm finding dv by dx. And in this case, you drop the power, which is the 3, and then x, and then you decrease the 3 by 1, and it becomes a 2. So I have to apply the quotient rule. So from here, my quotient rule, let me try and squeeze it within the same page. Yeah. So dy by dx is equal to v multiplied by du by dx. I'm applying the rule. So 1 over x times x cubed, which is x squared, minus u multiplied by dv by dx. So 3x squared ln 2x divided by v squared. So it's divided by x cubed all squared, which is x to the 6. And I'm going to leave it there. I'll leave it for you to simplify. You can take x squared common factor from the numerator and then simplify it with the denominator. Okay, let's take a look at another example, which might be slightly harder. Y equals ln x divided by x. Which rule am I using? Product, chain, or quotient? Quotient. Why? Because it's a function of x divided by another function of x. Okay, which is which? Now I need to identify u and v. U is always the one at the top. V is always the denominator. First step is to identify u and v. Second step is to differentiate both. Du by dx is 1 over x. We all know that. And dv by dx is 1. You drop the power, which is the 1. Decrease the 1, it becomes x to the 0. Anything raised to the power of 0 is 1. And then I apply the quotient rule. And the quotient rule is dy by dx equals v multiplied by du by dx. So it's 1 over x times x minus ln of x times 1 divided by v squared, which is x squared. And then you can simplify. This will become 1, and obviously you can simplify it or leave it. It doesn't really matter. Okay, let's take a look at the next example. I think we're on 4 now. And let's go y equals e to the x divided by x squared. Again, you need to ask yourself, which rule am I using? Chain? Not really. Product? Not really, because I don't have two functions multiplied together. But in this case, I have two functions that are divided by each other. And therefore, I am going to be using the quotient rule. So the first step, I now know that I'm using the quotient rule, is to identify which is which. U is always the function at the top. V is always the function at the bottom, which is the denominator. And then differentiate du by dx. And we all know that when you differentiate e to the x, you get e to the x. It stays the same. And then when you differentiate dv by dx, you get 2x. Brilliant. Let's apply the quotient rule. So dy by dx is equal to v multiplied by du by dx, so x squared e to the x minus 2x e to the x divided by v squared, which is x squared squared, so which is x to the 4. And again, you can simplify it. You can take a common factor from the numerator and simplify. Okay. So let's take a look at question 5.